Welcome to True Projects. In this video, we are going to explain about the project titled Opinion Mining Based Fake Product Review Monitoring and Removal System. Introduction. With the rise of online shopping, consumers heavily rely on product reviews to make informed purchasing decisions. However, the prevalence of fake reviews has cast doubt on the authenticity and reliability of these evaluations, leading to skepticism among consumers. The exponential growth of e commerce platforms has created a fertile ground for fraudulent activities, including the creation of fake reviews. This surge in fraudulent practices has eroded trust in online shopping experiences and distorted consumer perceptions of product quality and reliability. Traditional methods of review monitoring, such as manual moderation or basic algorithms, are inadequate in effectively identifying fake reviews. The evolving tactics employed by perpetrators and the sheer volume of reviews generated daily pose significant challenges to traditional monitoring approaches. Recognizing the detrimental impact of fake reviews on consumer trust and marketplace integrity, the project seeks to develop an advanced system capable of detecting and removing fraudulent content. By eliminating fake reviews, the project aims to restore trust and credibility in online product assessments, benefiting both consumers and businesses. Through the utilization of advanced technologies such as machine learning and natural language processing, the project endeavors to combat the proliferation of fake reviews. By safeguarding consumer interest and maintaining marketplace integrity, the project ultimately aims to enhance the online shopping experience for consumers and foster a fair and transparent marketplace environment for businesses. Objective. The project's primary objective is to develop a robust system capable of detecting and removing fake reviews from online platforms. By doing so, it aims to restore trust in online product evaluation and enhance the overall consumer experience in the digital marketplace. The project utilizes algorithms like random forest, Navy Bayes, MLP classifier, and voting classifier for classification and text classification tasks. These algorithms are chosen for their effectiveness in analyzing and categorizing data, particularly in the context of identifying fake reviews. Consumers benefit from the project by gaining access to trustworthy product reviews. The removal of fake reviews allows consumers to make confident purchasing decisions, thereby improving their overall online shopping experience. In conclusion, the project's overarching goal is to combat the prevalence of fake reviews on online platforms. By restoring trust for both consumers and businesses and enhancing the overall online shopping experience, the project aims to create a more transparent and reliable digital marketplace. Software and hardware requirements. Hardware requirements of the project are operating system of Windows, processor of i5 and above, RAM of 8 GB and above, hard disk of 25 GB and above. Software requirements of the project are application is Anaconda, primary language is Python, front-end framework is Flask, back-end framework is Jupyter Notebook, database is SQLite 3, front-end technologies used in the project are HTML, CSS, JavaScript, and Bootstrap 4. Working modules or flow of work. To implement this project, we have designed the following modules. The first module is importing the packages. This module involves importing necessary libraries and packages in Python that are required for data processing, visualization, feature selection, model building, and integrating with Flask and SQLite for the web application. Exploring the dataset, Yelp dataset. Here, the Yelp dataset is explored to understand its structure, features, and distribution of data. This step involves loading the dataset into memory, examining its content, checking for missing values, and gaining insights into the data. Data processing. Data processing involves cleaning and pre-processing the dataset to make it suitable for analysis and model building. This includes tasks such as handling missing values, encoding categorical variables, scaling numerical features, and removing outliers. Visualization using Seaborn and Matplotlib. Seaborn and Matplotlib are Python libraries used for data visualization. In this module, various visualizations such as histograms, scatter plots, and bar plots are created to explore relationships between variables, identify patterns, and gain insights from the data. Feature selection using formal data. Feature selection is the process of selecting a subset of relevant features from the dataset. This module involves identifying and selecting the most important features that contribute significantly to the predictive power of the model. Lexicon vectorizer. Lexicon vectorization is a technique used for converting text data into numerical vectors based on predefined lexicons or dictionaries. This module involves vectorizing textual data using lexicons to represent the sentiment or emotion of the text. Splitting the data to train and test. In machine learning, it's essential to split the data set into training and testing sets. This module involves partitioning the data into two subsets, one for training the model and the other for evaluating its performance. Building the model. This module involves building a machine learning model using the training data. Various algorithms such as logistic regression, decision trees, or neural networks may be used depending on the nature of the problem and the data. Building the model lexicon module for sentiment analysis. In this module, a sentiment analysis model is built using lexicon based approaches. Lexicon based methods analyze text by comparing words in the input text with entries in a predefined sentiment lexicon to determine sentiment polarity. Test blob. The test blob module refers to a specific testing framework or tool used for testing the functionality and performance of the application or model. Veda Sentiment. Veda Sentiment is a Python library specifically designed for sentiment analysis. This module involves using the Veda Sentiment library to perform sentiment analysis on textual data. Training the model. This module involves training the machine learning model using the training data. The model is trained to learn patterns and relationships within the data that can be used to make predictions on new unseen data. Flask framework with SQLite for sign up and sign in. Flask is a web framework for building web applications in Python, and SQLite is a lightweight relational database management system. This module involves integrating Flask with SQLite to implement user sign up and sign in functionality in the web application. User gives input. This module involves capturing user input from the web application interface, typically through forms or input fields. The given input is translated and pre-processed for prediction. The user input is pre-processed to prepare it for prediction by the model. This involves tasks such as tokenization, removing stop words, and vectorization. Trained model is used for prediction. The pre-processed user input is passed to the trained machine learning model for prediction. The model predicts the outcome or sentiment based on the input data. Final outcome is displayed through front end. The prediction or outcome generated by the model is displayed to the user through the front end of the web application, providing feedback or result based on the user input. Algorithms used. To implement this project, we have designed the following algorithms. The first algorithm is random forest. Random forest is a versatile machine learning algorithm used for both classification and regression tasks. It works by constructing multiple decision trees during the training phase and outputs the mode of the classes, classification, or the mean prediction regression of the individual trees. Random forest improves on the decision tree algorithm by reducing overfitting and increasing accuracy through the use of ensemble learning and randomness in feature selection. Coming to the next algorithm, which is Navy Bayes. Navy Bayes is a probabilistic classifier based on Bayes' theorem with strong independence assumption between features. Despite its simplicity, Navy Bayes is remarkably effective, especially in text classification tasks such as spam detection and sentiment analysis. It calculates the probability of each class given a set of features and selects the class with the highest probability has the prediction. MLP classifier. Multi-layer perceptron is a type of feed-forward artificial neural network composed of multiple layers of nodes, neurons. It is a powerful algorithm capable of learning non-linear relationships between input and output data. Each node in the network is a neuron that applies a weighted sum of its input followed by an activation function. MLP classifier is widely used for classification tasks in various domains due to its ability to learn complex patterns in data. Voting classifier. Voting classifier is an ensemble method that combines multiple individual classifiers and aggregates the predictions using a voting scheme to determine the final prediction. There are two types of voting classifiers: hard voting and soft voting. In hard voting, the predicted class is the mode of the predicted classes of the individual classifiers. In soft voting, the predicted class is the class with the highest average probability across all individual classifiers. Voting classifier often achieves better performance than any individual classifier by leveraging the wisdom of crowds and reducing variance. Comparison graphs. Comparison graphs offer a visual breakdown of how our models perform across essential evaluation metrics. Models are compared with the evaluation metrics accuracy, precision, recall, and FN score. This is the comparison graph. Here on the x-axis, we have the algorithm name, and on the y-axis, we have the evaluation metric score. Here, the red color represents the precision, green color represents recall, and blue color represents the FN score. The algorithm which is performing best in all the performance metrics will be used for prediction. This is the accuracy comparison graph. Here on the x-axis, we have the accuracy score, and on the y-axis, we have the algorithm name. Accuracy is a measure of the overall correctness of a classification model. It calculates the ratio of correctly predicted instances to the total number of instances. The algorithm which is performing best in all the performance metric will be used for prediction. Execution. To execute this project, first we need to open the code folder which contains the project source code files. This is the code folder. This is the static folder. This folder consists of files related to CSS, JavaScript, and Bootstrap. This is the templates folder. This folder contains all the HTML pages used in the project. It typically includes files like index.html, about.html, and more, which represent different pages of the website. This is app.py file. This .py file contains the information related to front-end logic. It includes code written in Python that handles server-side operations such as processing user requests, interacting with the database, and generating dynamic content to be rendered in the HTML templates. This is notebook.ipynb file. This is a Jupyter notebook file which contains a combination of code, graphs, and outputs all in one place. It allows users to write and execute code in individual cells, making it a popular choice for data science. This is model file which contains algorithm information which will be loaded into the project code during runtime. This is signup.tb file. This file is the database file used to store user information. First, we need to copy the path of the code folder from the address bar of the file explorer. Here, I'm copying the address. Now open the Anaconda prompt. Use the cd command followed by a space and paste the copied path and hit enter. This command is used to change the current directory to the code folder's path. Compile the app.py file using the command python space app.py. So here I'm typing python space app.py and hit enter. This command will execute the Python script and perform a runtime check for any syntax errors or logical issues. After running the app.py file, the Flask framework will host the application locally at the default address localhost, which is this, and port, which is this. Now copy this local link provided by the Flask framework. I'm copying the link and paste this copied link into any web browser. I usually prefer Google Chrome and hit enter. The homepage of the project is displayed in the browser. This is the front end built using Flask framework. If we are a new user, we need to register first. So click on sign up button here. Here we need to enter all these details to register. But I have already registered. So click on sign in button here. Here we need to enter the username and the password which we have registered, and then click on login. we have logged in successfully. Now click on fake link. Here we need to enter the messages, and after entering the messages, the application will predict whether it is a fake review or a genuine review. So here I'm entering the message. This is the message which I have entered. Now click on predict button. So here we can see the message which we have entered, and the result for the message is the review type is genuine. So it is a genuine review. Now let us enter some more messages. Click on fake link. So here I'm entering one more message. This is the message which I have entered. Now click on predict button. So here we can see the message, and the label for the message is the review type is fake. So it is a fake review. Let us enter some more messages. Click on fake link. So here I'm entering one more message. This is the message which I have entered. Now click on predict button. And here we can see the message which we have entered, and the label for the message is the review type is fake. So it is a fake review. Let us enter one more message. So I'm entering one more message here. This is the message which I have entered. Now click on predict button. So here we can see the message, and the label for the message is the review type is genuine. So it is a genuine review. In this way, just by entering the messages, we can predict whether it is a genuine review or a fake review. Now click on sentiment link. Here we need to enter the messages. After entering the messages, we will predict the percentage of the sentiment for a particular message. So here I'm entering the message. This is the message which I have entered. Now click on submit button. So here we can see the sentiment of the message is 97% positive. And here we have the score table, that is the sentiment metric. Positive is 0.827 percentage, neutral is 0.173, negative is 0.0, compound is 0.97. Let us enter some more messages and check the sentiment. So here, click on sentiment link. Now I'm entering one more message. This is the message which I have entered. Now click on submit button. So here we can see the message, and the sentiment for the message is 97% positive. And here we have the sentiment metric. Positive is 0.207, neutral is 0.713, negative is 0.08, compound is 0.97. Let us enter some more messages. Click on sentiment link. So here I'm entering one more message. This is the message which I have entered. Now click on submit button. So here we can see the message, and the sentiment of the message is 77% positive. And here we have the score table, that is the sentiment metric. Positive is 0.411, neutral is 0.589, negative is 0.0, compound is 0.77. In this way, by entering the messages, we can predict the sentiment of the message in percentage. Now click on sign out button here. The conclusion of the project is the project achieved success in creating a strong system capable of effectively detecting and removing fake reviews from online platforms. This system helps to maintain the integrity of online product evaluations by filtering out fraudulent content. By analyzing fake review data, the project identified patterns and trends, offering valuable insights into the prevalence and characteristics of deceptive practices. This understanding contributes to the development of more effective detection algorithms and strategies. Through the removal of fake reviews and promotion of genuine feedback, the project enhanced consumer confidence and loyalty. This increased trust leads to higher engagement with online platforms and ultimately translates into improved sales for businesses operating within these platforms. The project collaborated with industry partners and regulatory agencies to establish standards and best practices for combating fake reviews and promoting transparency in online commerce. This collaboration ensures a unified effort towards maintaining trust and integrity in the digital marketplace, benefiting both consumers and businesses alike.
Thank you for watching video. For more projects please visit our website www.trueprojects.in. For updates on latest project videos, please visit True Projects YouTube channel and subscribe.